Lesson 5.2, we're going to look at solving two-step equations. And we'll notice some similarities between what we did when we solved one-step equations. So if you look at page 260, example 1, Nala and two friends spent $21 on movie tickets and a box of popcorn. How could they figure out how much each movie ticket costs? So you can see from the picture, Nala and two friends. First of all, notice it's three people. Some people see the two and think two, but actually three people. You can see the popcorn costs $6. And so we could draw a bar diagram to start with here. Total spent was $21. We have 3 movie tickets. M for movie ticket or T for ticket, whatever variable you want to use there. We should probably define our variable. Anyway, so the equation, we could have 21 equals 3 times M plus 6. Or you could switch that around. You could put 3M plus 6 equals 21 would be the same thing. Okay? So what we're going to look at in this lesson is not only just setting up the equation, but then actually solving and figuring out how much the movie ticket costs. So some of these problems you guys might be able to look, you might be able to figure it out on your own just by looking at what's going on here, figure out how much the movie ticket costs. That's not what we're going to do, because a lot of these problems you're not going to be able to figure out the number. It may be a decimal or something, not very nice number. It may be a repeating decimal, okay, stuff like that. So we're going to show our work of what we're doing. So like the book's showing here, these are going to be the steps we're going to do. I'm going to show this a little bit differently. So I'm going to show this using the equation that I wrote. So you guys can see what's happening. If you remember when we solved equations, we solved one-step equations, and we actually did this in 6th grade. We did the opposite operations. In a two-step equation, we're also going to do the opposite operations. Kind of works actually in the opposite order of operations. So in this case, on the left side there's multiplication and addition. Normally we would deal with the multiplication first, but we're kind of working this thing backwards, and so we're actually going to deal with the addition first. What we're trying to do, we're trying to isolate our variable. We're trying to get that M by itself. So in order to get the M by itself, the first thing we got to do before we do that is get the 3M by itself. So to get the 3M by itself, we can look and we can say that over on the same side of the equation they are adding 6. So to get rid of that, we would need to subtract 6. Okay? This equation is like a balance. So if these two things are equal and then I take away the same from both sides, they're still going to be equal. Okay? If you can visualize like a balance scale. So 21 minus 6 then is 15. And again, at this point, we can probably tell what's going to happen. But just for practice, in case things don't come out evenly, notice the variable is being multiplied by 3. So the opposite operation, we are going to divide by 3. And again, as long as we divide by 3 on both sides, keeps our equation still balanced. 15 divided by 3 is 5. And that means that a movie ticket costs $5. So these are the steps that you need to show. This is how you need to show your work to do these problems. And you'll be asked to do this the same way when you're in high school and stuff. So don't think, oh man, I'm got to do all this work for Mr. Schmidt. Your other math teachers are going to have you do the same thing. Okay, so I'm just helping prepare you for when you have them as well. More of the same. We look at the try it. Andrew rents bowling shoes for $4. And he bowls 2 games. He spent a total of $22. And so the question is, how much was the cost of each game be? The bar diagram here is kind of a visual that hopefully will help you to come up with this. So $22 total. The shoes were $4, and then he played 2 games. The other bar diagrams the book's doing is kind of showing steps of how you would solve the problem. I'll show you what you would put in those situations, but don't worry about those parts too much. But like I said, writing using the bar diagram might be a good way to help you come up with your equation. So a couple ways you could write your equations. You could have something like 2b plus 4 equals 22. If you did this equation like we did earlier, our first thing is trying to get that variable term by itself. They're adding 4 means we would need to subtract 4. And then they're multiplying means we need to divide. And then you can see each game would cost $9. Another way of doing this, the bar diagrams, just to show you what they're doing here, they start just kind of breaking this apart and gradually working towards figuring out what each game is. So first of all, they take off the $4 and say, well, there'd be $18 left for the bowling games, and then they split that in half and then see that's $9 each. Okay. And again, a lot of times you guys are doing these problems, they might specifically say write and solve an equation. You have to write an equation. Another way of doing this, you could say we have $22 minus the $4, and then if we would subtract off our shoe costs and then divide that by 2, that would tell us what the cost would be for one game. And if you'll notice, that would give you the same answer. Okay. And if you do that, technically you don't have to have the parentheses in the numerator. If you write it that way, it's assumed that we would do the subtraction before we do the division. Example 2, John has a $21.61 balance on a gift card that can be used to purchase online music. He bought some songs that each cost $1.29. Now he has $10 left. How many songs did John purchase? So there are different ways of doing this. The book's showing you one way of doing this. To me, we've got some other easier ways that we could work this problem out. So there's a $21.61 balance. If we take that minus 10, that would be equal to $1.29 times D. So if you think about this, $21.61 minus 10 is going to tell us how much money that they spent. $1.29 times D is also how much they spent. So that's one way of doing it. Or another way, you could say $21.61 minus 10 divided by $1.29. Okay. And again, there's nothing wrong with what the book's doing. And it just kind of depends on your thought process, what you think. And I mean, looking at it now, it's really not too bad. Maybe it makes more sense than what I'm doing. I don't know. They're saying we start with $21.61, and then we subtract $1.29 per song, and then that gives us a $10 balance. The thing we have to watch for on this problem is when you guys go to solve this problem, People make mistakes on this sometimes in figuring out what their next step is. In other words, a lot of people get to this step and then they say, oh, they're subtracting, I need to add, because we haven't had a whole lot of practice on solving these yet. So that's one bad thing about doing it this way. What you can do, you can add the opposite here if you want. That's like a negative 129D. And what you need to think about, that 2161 in the beginning, that's what we need to get rid of to isolate our variable, to get our variable by itself. So if you can just think about, that's a positive 2161. So to get rid of a positive 2161, we have to subtract 2161. Okay? The bad thing about doing it this way, like the book's showing, is that we're dealing with negative numbers also here and stuff. You know, $10 minus 2161. You know, not quite as easy as maybe some of those other ways we're talking about it. And if that doesn't make sense to you, just understand if you add the opposite here, we could rearrange this as negative 129D plus 2161 would be the same thing if we just switch that around, if that helps you to see better that they're adding and we need to subtract. Okay, so it's just kind of in a different form that makes it a little bit more difficult for us to see maybe what it is that we need to do next in order to solve for our variable. Example 3, how many, the number of trumpets players is 2 more than 1/4 of the entire band. How many students are in the band? And you can see 18 students play the trumpet. So what they did is looked at the statement here. So trumpet players, which is 18, means equals. This would be kind of backwards from what the book's doing, but 2 more than 1/4 of the entire band. So if B is the total number of students in the band, 1/4 of the band would be 1/4 B, and then 2 more than that would be plus 2. Again, technically 2 plus 1/4 B works here also, but just to be in a good habits of doing this in the right order. In other words, if they said 2 less than 1/4, we would need to do 1/4 B minus 2. So if we do the same for the more than and the less than problems, we'll be more consistent on how we set those up. Once we get the equation set up, you can see the book's subtracting 2. When we do these problems, we're not going to write all this stuff out like the book's doing. They're rewriting the whole problem. We're just going to say they're adding 2, we're going to subtract 2. And then there's 2 ways of looking at this last step. The way the book's doing it is they're saying if we multiply by 4, 1/4 times 4 would be 1B, which is the same as B. The other option you have, you could say that the B is being multiplied by 1/4, and you could divide by 1/4 on both sides. If you divide by 1/4, remember to divide fractions. What do? Keep, change reciprocal. And so that would be 64. Again, same answer as what the book got doing it their way. One thing I forgot to mention so far, when you guys do these problems, the nice thing about them, you can always put your answer back to the original equation and see if it works. You can check your answers, okay? So if we put 64 back into our equation, as long as we set the equation up right, then we can check to see if this works. So 1/4 of 64, that'd be like 64 divided by 4. And if you divide that out, that would be 16. And 16 plus 2 is 18. So that works. So as long as we set the equation up right, then we know that we have the right answer. So that's something I really like about these problems.